Okay, so 5.8, and today what we're going to do is just build on what we did yesterday with rational functions and then do a bit of integration. So first thing, as a warm-up, just practice your skills for the partial fractions and convert the three algebraic fractions on the screen into partial fractions as quickly as you can. Then unpause the video and we'll start to look at today's work. Okay, so those three questions you just did are going to be the three we look at today. I'm going to go through things kind of quickly, and yeah, it'll be a short video. So the key fact and the reason why we're learning about rational functions now is when we have an algebraic fraction where the denominator is linear, well, we can integrate that. We know it's going to be a log of some kind, and we know that the log is going to be the modulus of the denominator, like this. And then if we're thinking about this, if it's originally a k, then I'm going to need a k in my answer as well to get that k when I differentiate. And then when I differentiate this result, because of the a here, that's going to, using the chain rule, that's going to multiply by the a. So I also need to divide so that that cancels out. And now if you try differentiating the right-hand side here, using the chain rule, you'll see you get the integrand, which means we can use the rule in reverse. So you did the partial fractions for part A, and when you did that, it's actually the same one we looked at yesterday. You have that kind of whole number part, x cubed plus x. Then you have like minus a half of x plus 1, and then plus 3 over 2 x minus 1 dx. That's what we did yesterday. If you're not sure about that, look back at it. And then we integrate this term by term. So x cubed, so a quarter x to the power 4. X is a half x squared. And then these, using the result above, are just going to give us our logs. So all I'm doing at this point, oh that's a mess, that says x plus 1, is using this form above with k and with a. A in both cases is just 1, and k is minus a half and 3 over 2. And then the real thing we're just going to look at today is how we combine these into one log. And that's another skill you've done before, but to write our answers completely fully for questions like this, what we're going to do is we're going to take the coefficients in front of the log and then we're going to bring them in as powers, and then we're going to use either multiplication or division to combine the two logs into one, and the magnitude, the modulus signs, can just go around the whole thing. So as I'm doing this, I'm going to have the magnitude of, this is going to be my numerator because it's positive, so x minus 1, and then the power is 3 over 2, because that's the coefficient, and the denominator is going to be x plus 1, and that's going to be to the power a half, because of the coefficient here, plus c. So that's my result for part A. Obviously, I'm hoping that your log skills are pretty good, but if you need a recap, what are we doing there? Well, a log of x is log of x to the power a. We're using that rule, and then we're using the rule of log x plus log y is log of xy. We're using that, and we're using the fact that if it's a subtraction instead, then it's a division. And really, those are the rules that we're combining. So what I'd like you to do is, you've already done the partial fractions part of this, is try the other two questions, one here and then one on the back, and then you can check your answers versus mine. Okay, so hopefully you've done it. Just really quickly, a note on the partial fractions here. Because it's only one repeated linear factor, we know straight away that 3x plus 1 over x plus 2 squared, well, that's going to be a over x plus 2 plus b over x plus 2 squared. And that's a pretty good place to use the equating coefficients method, because we know that 3x plus 1 is then going to be a times x plus 2 plus b. We don't have to multiply the b by anything. So looking at the x coefficient, I can see that a equals 3. And then looking at the k coefficient, I have 1 is 2a, so that's 6 plus b, which tells us that b equals minus 5, which means my integral I is the integral of 3 over x plus 2, take away 5 over x plus 2 squared dx, and then integrating those two terms separately. The first one gives us the log, so that's 3 log of modulus x plus 2, using the same rule. But the second one, and this is important to remember, if the denominator is not order 1, then we don't get a log at all. We're just going to increase the power of this by 1, so it's going to go from power minus 2 to power minus 1. And actually, integrating that, I just get 5 over x plus 2 plus c. And as normal, if you've got any doubts about your integration, you just check it with differentiation. If I differentiate that, multiply by the power, becomes negative, reduce the power by 1. All good. Alright. I told you it would be super quick today. Hopefully that's a relief. The last one, I want you to have a go at it. If you haven't done so already, try it out all the way. And see if you can figure out how to split the second fraction up. What I'm going to say to you is there's two ways to do this. Sorry, that's not what I mean. What I mean is you're going to split this into 3 terms in total. And 3 things that you can integrate. So have a go. Alright, you've tried it. To save time, I'm just going to show you mine. So first of all, we've got this irreducible quadratic root. So we use our bx plus c. We use our substitution. And in combination, this is the way I did it, with some equating coefficients, I get a is 2, b is minus 2, and c is 2. And then that means I can change the integral to 2 over x plus 1 plus 2 minus 2x over x squared plus 1. And the first one of these, super easy to integrate. But this term here is a bit more challenging. And what we're going to use is we're going to use the fact that if I've got a plus b over x squared plus 1, well, that's the same as a over x squared plus 1 plus b over x squared plus 1. So I can just divide this into 2 fractions, which is what has happened here. So I've integrated the first term. This gives me this, but this term gets split into 2. So as I do my integral, I'm going to get 1 over x squared plus 1 and then 2x over x squared plus 1. And then here's the thing, when I'm trying to find a log, I need the numerator to be the derivative of the denominator. And in this case here, that fraction is like f dash of x over f of x, because the numerator is the derivative of the denominator. And what that means is that the integral is log of f of x. If we think about that for a second, if I differentiate log of f of x, I do 1 over f of x, and then I multiply by the derivative of f of x, which is f dash. And so this here is going to integrate to log of x squared plus 1. Simple as that. This term, I forgive you if you didn't remember this straight away, but this is a standard integral. 1 over x squared plus 1 gives us tan inverse. And so what we actually end up with for this example is we end up with a straight up linear log here. We end up with a inverse trig function, and then we end up with a quadratic log, because here the numerator is the derivative of the denominator. So we split into 3 parts, and then just for neatness with our final answer, even though they came about from different parts of this, we combine the 2 log bits together. We've got the subtraction, so it's divide, so it's log of x plus 1 squared over x squared plus 1 plus 2 times tan inverse of x plus c, always plus c. So hopefully you're following that. Obviously let me know if you've got any questions at any point, but try all the exercises and the exit ticket, and then let me know what you want to go through when we next speak. All the best.